It's 3 o'clock in the afternoon. We are in Spain, Malaga, 100 meters from the beach. So it's perfect time for siesta, not for graphs. So I really appreciate your presence here. I will try to do my best to keep you interested in the presentation. And I can promise you that this is going to be probably the easiest to follow talk during the whole event, okay? Just to ensure you're in the right talk, my name is Fernando Pérez, and we are going to talk about graphs, why graphs are a so powerful tool to model information and to extract insights from them, the problem of big graphs, why big graphs are so difficult to compute, how big data can help us to process this kind of graphs, and as we are in the business track, we will show you how we are using big graphs and big graphs analytics in our business environment to gather insights. Let me introduce you a little bit our business environment. We work for a research lab called Bitmon Lab. Bitmon Lab belongs to a group of companies, most of them dedicated to the content creation, digital content creation, and digital entertainment, okay? What usually is known as the digital economy. The main company from the group is TED Worldwide. We are near 2,000 employees all around the world with presence in more than 70 countries in the world. And our natural partner are telco carriers, okay? We are helping telco carriers in their digital transformation, providing them with digital marketing, mobile financial services. We also provide them with analytics, top-up prediction, churn prediction, customer segmentation models, and they are the natural partner of TED. We also have a film animation studio. How many of you have seen Planet 51 or Mortadelo y Filemón? Okay, we started in 2002. In Ilion, there are more than 350 experts from all the world working there, from engineers, programmers, to digital designers. Our last title was published 2 years ago, Mortadelo y Filemón. Both films were awarded by the Spanish Film Academy with the Goya Award, okay? Now we are working in another film. Another important part from our company is Piro Studios. How many of you have played Commandos anytime in your life? Okay. My generation has spent hours and hours. Our notes in the career go down because this game, it was #1 in many, many countries in Europe. It's considered to be between the top 10 games developed in Europe ever. Now Piro is developing games for social networks, Facebook, Orkut, and recently, obviously, we are developing games for mobile devices, iOS and Android. Our last 2 titles, Evolution Planet and Super Soccer Club. Super Soccer Club has been awarded with the best iPhone and iPad game in this year Game Lab event, the most important gaming event here in Spain. And last but not least, we have the UTAD, the Universidad de Tecnología y Arte Digital. As you can imagine, with all this knowledge and expertise in the entertainment and digital industry, in this university, we teach our students all this knowledge, and it's mostly focused in 3 different kind of degrees oriented to engineering, game development, computer science. We have also degrees oriented to the digital business administration, and of course, animation and digital design. So it's one of the key factors of success from the university, that we are able to mix students from all the different degrees working together to bring an idea into the market, from the idea into the design of the idea, the construction, the development of the idea, and the viability of the business from behind the idea. All them working together, trying to prepare the entrepreneurs of tomorrow from this country, okay? So now let's go into the graphs theory. I will make a little introduction so you can understand better what I'm going to tell you later. How many of you have seen this image before? Okay, quite a few. I'm showing, this is the city of Königsberg, and those are the bridges of Königsberg. And this image is ubiquitous, is in almost every presentation about an introduction to graphs, okay? So for this case, I wanted to be a little bit original, and I've changed the image. It represents the same concept, the city of Königsberg, and its bridges. Why do I show you this to those who haven't seen this before? Because graph theory is supposed to be born with the publication of Leonard Euler paper, 7 Bridges of Königsberg, where he solved, in fact, mathematically, the problem of is it possible to visit each part of the city, crossing one and only one each of the bridges, starting and finishing in the same city area. And part of the key of success of Euler was his capacity of abstraction from city areas and bridges into the concept of nodes or vertex and links or edges, okay? and he demonstrated that a graph at least needs to have all of its vertex, all of his city areas in this case, need to have an even number of bridges or links in order to have an Eulerian cycle. As you can see, this is not the case because almost every city area has an odd number of bridges, so you cannot have an Eulerian cycle in this graph. And as a curiosity for those who have seen this image before, do you know who was the person who proposed Euler to solve this problem? Okay, here I get you. It was Immanuel Kant, okay? The famous philosopher was the person who proposed Euler to solve the problem. Okay, so graphs in the real world. Graphs, there is a very famous phrase from Neo4j, graphs are everywhere, and it is true. We've been using graphs since ever. The humans, we are a social animal, social mammal, so we've been using graphs to model relationships between people. We've been using graphs to determine our buying patterns, for example, and our livelihoods. We've been using graphs, of course, recently, it's fashion of online social networks, Twitter, Pinterest, Facebook, all of them. Of course, mobile communications, organizations, security, fraud, crime is organizing graphs, groups, distribution, and recently even in health. There are new teams working to map the body, human body and human diseases as a graph and trying to cure diseases using these techniques. So, as I told you, a family tree is a kind of graph. It's been present with us since ever. Social networks, and in this case, look, it's not Facebook. It's a phone call social network. Which better social network than a calling network? Which link do you think represents better information? A friendship relationship between two Facebook users? Or a link between two persons who are calling themselves at least 5 times a week and every call after 8 p.m. Which information is richer, right? Here in Spain, we usually say, you're more fake than a friend in Facebook, right? So, here we have another network, the transportation networks, economic network. So you can find them everywhere. Even recently in Nature, it was published this graph, an incredible graph, the first mammal brain from a mouse map, the neural network map as a graph, okay? And of course, maps are also in graphs, in art, sorry. Here is the work from Tomás Saraceno. There's not too much resolution in the image, but it's going to follow us during the whole presentation as it is the GMAS I've used as the background from the title slides, okay? So now we've seen that graphs are everywhere. Why are they everywhere? because they are a very natural way of representing information and concepts. Everybody has ever taken a pencil and a blackboard and have drawn a diagram representing objects and relationship between those objects, right? That is a graph. Graphs has the power just by its visualization. Many times it's meaningful. You can find interesting points in the network just looking at the network, interesting zones, interesting vertex. And believe it or not, networks are completely present in our lives. They determine our facility to find a new job. They determine how a disease is going to spread through a population, our propension to consume. The information can flow between both nodes in its sense, okay? While in the directed graphs, information can only flow from one vertex to another depending on the direction of the link, right? For example, Facebook is a sample of an undirected network. Once someone accepts the friendship request from another user, a friendship link is created between both users, but there's no sense. While, for example, in another online social network like Twitter, it's a directed network. I can be a follower of Justin Bieber, but he doesn't have to be my follower, okay? Another way to classify graphs is weighted and unweighted. When we have an unweighted graph, there's no, all the links represent the same. It's just a connection between both nodes, but there are no links more important than another ones. While in weighted graphs, we want to differentiate one link from another depending on that weight. For example, in this example, you can see a graph with 6 nodes representing 6 cities, and the links represent the distance between those cities, okay? For example, yesterday I came by car from Madrid to Malaga, so I need to make 331 kilometers per plus 202, okay? 333 kilometers. Okay, another curiosity. How many graphs do you think we can have with 3 nodes? With just 3 nodes? Okay, here we have one, okay, no links, but it is a graph. We can have 3 more with just 1 link, 3 more with 2 links, and a complete connected component with the 3 nodes linked, okay? So with 3 nodes, we can generate 8 nodes. Imagine you work for the government and you need to decide what roads you want to build between all those 6 cities. Is it an easy decision or it is complicated? How many roads you could build between those 6 cities? 32,000 possible roads between all those 6 cities, okay? So because in fact, in an undirected graph, we can have 2 to the power of the sum of the number of nodes minus 1, okay? In the case of directed graphs, this number is 4 to the power of that, because between 2 nodes we can have no link, one link in one direction, another link into another direction, or a link in both directions, okay? The natural way to represent graphs in computation, in computer science, is with the adjacency matrix, okay? It's a square matrix where we represent as columns and rows the vertex, and the intersection between those rows and columns represent the edges between those vertex, okay? In the case of unweighted network, this value is always 1, true, something that identifies that there is the presence of a link. In the case of weighted networks, this intersection contains the weight of the link, okay? If the If the graph is undirected, then the matrix is symmetric. The presence of a road between, in this case, Granada and Almeria is also, you can see in the other side that it exists between Almeria and Granada, okay? Because we choose here to represent it is undirected. Okay, and once we have a network, typical question that everybody, the first question when people see a network is, I want to know which is the people, which are the nodes important in this network, right? Everybody wants to know who's the influencer, the famous phrase. And the correct answer always with just this information must be, it depends. It depends on what is representing the network, what do you mean by an edge, what do you mean by a vertex, and it depends on what is relevant for you, okay? So commonly it's accepted for different kind of prestige or importance inside a network. How well connected is a node, which is the prestige or the power of his neighbors, how close is it to the rest of the network, and his ability to intermediate in that network, okay? So let's start with the simplest one. The simplest one is the degree centrality. This is a centrality measure, very easy to calculate. It's the number, the intuition is how well connected is the node, how many connections does it have, and it's just counting the links that this node has. If the graph is a directed graph, as we see before, this metric can be split into in degree, the number of input links, and out degree, the number of output links. Okay? For example, in Twitter, the number of followers is the number of input links I have, then the out degree, the number of people I'm following. But this measure has to be taken into account with some carefully. There is a very nice paper about measuring the user influence in Twitter, the million follower fallacy. If you have 1 million followers, this doesn't mean that whatever you say is whatever people is going to do, okay? So, but with this example, this is the contra example, okay? It's a measure that it's very easy to understand, and I bring here a very let's say stupid example, but it's very funny. We have here a typical graph in the academic world. It represents sentimental relationships between students in a high school in the United States. Blue nodes are boys, pink nodes are girls, and there is a link if they have had a sentimental relationship. And here, with this image, you can fastly guess who was the quarterback from the football team, right? There's someone in the upper right part who has many, many relationships. Okay. Another very famous centrality measure that is PageRank. Okay? PageRank was created by Larry Page and Sergey Brin. It's property of Stanford University, but Google has all the rights over the patent. Okay? What PageRank intuition capture is that all the influence of the people who's linking to me, I get this influence. Okay? Someone important is linking to me, I'm also important. But the importance of these people is shared among all the people he's pointing. So if someone very important links only to me, all his important is for me, great. But if he's also pointed to 1,000 users, it's divided by 1,000, okay? The measure that will help us to identify people who's able to intermediate in the network is betweenness centrality. It counts how many paths between two nodes pass through a concrete node. So with this metric, we identify which of the nodes from the network are able to control all the information flowing through this network. Okay? I bring here a very simple example where we have two components just connected by one node. All the peripheral nodes has betweenness centrality 0. They are not in the middle of no communications. And the three central nodes has all the betweenness centrality shared between them. Okay? And now let's move from concrete vertex metrics to group of vertex metrics that are also very important, topology metrics. In this case, I just bring a couple of them. The most important probably, this one is K-cores. K-cores is a very important tool to identify groups in the network that are especially well connected, okay? This is a technique very used for fraud detection, for example, resiliency of networks. In this case, I have a network with a K of 3. That means that every member from this group needs to be connected to at least 3 other members of the group, okay? So let's see what happens when I remove a link like the one dashed over there. Then the K-core is almost destroyed, and we keep only the left part of the network, the right part of the network, sorry, with these 4 nodes. So for example, in terms of resiliency, imagine this is a critical infrastructure network. With these techniques, you identify which links must be double or special care with them, okay? And as I told you before, it's very typical in fraud networks, okay? When you start to see people that with other techniques it's quite difficult to see that they are in many times working together, okay? And the last technique I wanted to show you is, of course, community detection. Community detection, the objective is to identify groups of users also linked together. It's not limited by number or by size, and it's one of the most complicated algorithms to compute in a network, okay? Usually it's used by a concept called modularity, and the maximization of this, finding the perfect groups is computationally is a really hard problem, okay? So now we understand what is a graph and the typical measure we use over graphs. Let's see what's the problem of the big graphs, okay? So, sorry. So working with big graphs, it's not only a problem of size, okay? It's not only about the size. It's also because the networks in the real world are dynamic. Everything is changing. Imagine how many new relationships are created in Facebook in every minute, how many phone calls in a telco carrier every day. So every measure from those we've seen before need to be contextualized for a concrete moment in time and need to be constantly recalculated because they are obsolete. And many times we cannot apply techniques based on localization to compute those graphs, okay? We also, as we see, the typical way to represent a graph is with a matrix, with a adjacency matrix, and matrix computation is always iterative, okay? And as well as when we see, for example, algorithms like PageRank, if my influence depends on my neighbor influence, once one of my neighbors changes his influence, my influence changes, so all my neighbors' influence change, so it's a cascade problem, it's an iterative problem. It's like the butterfly effect, you know that? A butterfly flying in one part of the world can generate a storm in the other side of the world. So it's completely iterative process, and as many of you would know, MapReduce and this kind of paradigm from big data doesn't work very well with recursion and iterative paradigms, okay? And however, of course, the problem about size, also size matters, okay? Because when we have many nodes, we are going to have many by many links, and the possible path between two nodes is going to be exponential. And many of the graphs we can try to compute today doesn't fit into the memory of one only server, so need to be split into several servers. And some kind of problems, as we see, modularity or strongly connected components are really hard problems to compute. And if you have the probability of having a strongly connected component in a big graph is higher, obviously. And if the graph per se is a strongly connected component, is it's incredibly hard to process that graph, okay? So now let's see what can we do with big data to process those big graphs. Okay, in 2010, employees from Google published a paper called explaining the Pérez model. By the way, Pérez is the name of the river we saw at the beginning in Königsberg, okay? So it's the river of Königsberg. And these people published the paper explaining this paradigm to process graphs. That is a really smart approach to process big graphs. It's based on it's a vertex-centric paradigm. It's like, think like a vertex, okay? So the program with Pérez model is like an infinite loop divided into super steps. Each loop is a super step, okay? And in each super step, every vertex at the same time in parallel perform the same function, okay? The input parameters for this function are the message the node is receiving from the previous step from his input links, and as a result of that function, the node can change its states, or it can generate new message to its neighbors, okay? So I think this is better understand with a simple example. You don't even need the pseudocode. Let's compute the source shortest path from node A to the rest of the network. How will it perform with the Pérez model? Okay, in the first step, the A is initialized with a 0 value, and it propagates his value and the weight of his link to his neighbor. He only has B as a neighbor, so it propagates that value. In the next step, then node B updates his value to 1, it was infinite, and propagates his new value to his neighbors, 1 plus the weight of the link. And we go on, then now in the third step, nodes C and D are updated with 10 and 3, and propagates its value to node E, who's receiving 2 different messages. He's going to compute the minimum between both, so it updates to 6, and he propagates a new message to their neighbor. So D is not going to update its value because 9 is bigger than 3, but C that has before a 10 is now updated with a 7, and there are no new messages, so the algorithm stops here, okay? Okay, with the new paradigms based on working on memory, like Spark, GraphX implement this paradigm of Pérez with GraphX Pérez, and it's the same concept, but using the famous RDDs from GraphX. And in those RDDs, we represent the vertex from the networks. We have another RDD for the edges, and there is an abstraction called triplet who has the vision of the full link with the source and the target. In this case, the message is the user-defined function and has visibility over the whole triplet, the source, destination, and the link. Can update parameters from the vertex, and in this case, as in the Pérez model, the program finishes when there are no more messages to send, okay? Okay, so now let's see how this is our architecture. This is how we apply analytics in our business environment. We have a data ingestion layer. As we are a mobile-oriented company, mostly we have specialized in event processing, events that came from our games and our applications, and we process them with the Stream API that's able to capture those events and extract the information and push it into the data lake. But we also can process batch files from a telco carrier, for example, and we have also crawlers, for example, to crawl Twitter or to crawl Google Play, for example, to gather opinions, user opinions from our games, etc. Once the data is in the ingestion layer, then we can create simple alerts, near real time, basic things, but many times interesting for our business lines. But once the data is in the data lake, we have a business intelligence layer, the traditional way, answering questions driven by business needs with Tableau that users can access through our web portal. But we also have a data science layer where we apply specific algorithms from prediction to segmentation and classification for a special request for our business lines, okay? For domain-specific analytics. This is the part where we provide services to all our ecosystem. But we also generate analytical products, and in this case, we have three main products. One is InGraph for Twitter, the other one is Social Button, and a web classifier. If we deep dive a little bit into the architecture, here we can see our ingestion layer. In the case of the Stream API, it's based on Spry and Scala, Spark streaming with Scala and Akka. And the crawlers are built on Java. The store connector allows this layer to talk with our storage system. We mainly use HDFS with some structures over it in Hive, some HBase, and MongoDB also. Okay. One good thing from our Stream API is that it allows us with completely heterogeneous sources. It's scalable. As we stress the system, it automatically allocates new resources. And the events sent to our data lake by application are completely schemaless. They just need to identify which application is sending the event, the type of event, and then they will gather the insights they need later with our data science layer. If they follow a specific pattern, then they get from day one a custom standard analytics with the business intelligence layer, but they can send whatever they want. And in the case of graph analytics, when we receive business events into the data lake, then we have an ETL process that is able to transform those events into a graph. Okay, so we have graph modeling rules that allow to identify from the events which are vertex, which are edges between those vertex, and then we process them with the graphics paradigm from Spark, and sometimes with standard machine learning algorithms with Spark MLDIF, okay? And this is the high-level architecture of one of our products, for example, analytical products that we can sell, not only for our business lines. In this case, InGraph, where we have the analytic layer we saw before. There is a resource manager who's able to identify when the system is stressed to allocate new resources. This session manager, that many of the analytics we perform sometimes doesn't finish in seconds, needs perhaps hours to perform. So when a user launches one work of this kind, he obviously doesn't want to lose it. So all this information is kept through his session manager, and the scheduler is able to deploy this result when it is finished. So the user is able to access to it once he came back to the tool. The dispatcher is a broker of all the works in the infrastructure, and our front-end architecture is the standard JavaScript architecture with Angular and Node and visualizations with D3. Okay? So now I would like to go into some of the use cases that perhaps this is the most interesting for you, how we are using big data in our business. Okay? So I hope you have seen already the InGraph Hall of Fame. It's an infographic we are using to show who's getting more impact in the event. It's built over the ingraph engine, okay? And here you can see the coolest teacher that is, for example, from the speakers who's getting more retweets and more influence. The trendsetter, in this case, he doesn't need to be a speaker from the event. Oh, sorry, you're not watching it. Sorry. Let me. Okay, here it is. For example, Nikki is here as the bookworm because he's all the time tweeting about the event, and here you can see the typical information as tweets evolution, word clouds, and the top tweets, okay? This product is an infographic, is something we have built specifically for this event, okay? But it's based on ingraph for Twitter. Ingraph for Twitter is this product. Here we have an environment with all the sponsors from the event, from Jay on the Beach, all the sponsors from Diputación de Málaga, Clicun, all of the sponsors are here. And here you can see all of these are Twitter users, and you can see here communities between all those root accounts, okay, what we call root accounts. So here you can start to see synergies between all of them, because in this case this is our area of interest. And it's not only defined as main accounts, it's also defined as main message. So with ingraph, we extract a micro universe from Twitter around the information that matter to us. Special accounts and special hashtags, people who's following those accounts and people who's talking about those hashtags. Here the hashtags are Jay on the Beach, of course, in the different forms it could be, DevOps Málaga, and Big Data Málaga, and Scala Málaga. Here, for example, we can see people who's talking about Jay on the Beach and Big Data Málaga, okay? Here we have another environment where we have just the key speakers, the key speakers of the event and the event account. And the good thing of the tool is that you can make something like a visual query over the graph, right? For example, you can say, okay, from all these people, I want to see people who talk about, whose tweets contain, for example, great. They really like the event, great. So then the graph is filtered. I'm performing a visual query online, and here I can see, for example, people here who's following three of the key accounts of the environment and who's saying that we are glad to announce another great company from Malaga. Okay, we can go further into our filters, and then we can, for example, filter. I want to know people who at least the number of route followed. At least 2 routes. And here we have people who are saying that Jay on the Beach is great, and they are following at least 2 of the root accounts, okay? This one here. And I want to color them by the number of tweets they have published ever in this color. So the bluest ones are the ones who have more activity on Twitter, okay? This one, for example, have more than 7,000 tweets. When we did deep dive into one of the accounts, of the root accounts, then we can see more metrics as how his followers are evolving, how are its followers, their followers, how many followers does they have, how many following does they have, a distribution, the geography of those followers, and the same for the hashtags. Here we can see the hashtag, we are always handling the same filters I applied in the other view are applied here. So this is people who are saying that the event is great, okay? And they are following at least 2 of our root accounts. And here I can see how the hashtag is evolving with during a calendar, when is the people talking more about the hashtag, the word cloud. This is typical stuff from Twitter analytical tools, and what we bring is this kind of metrics that we identify with our graph analytics algorithms, important people in the graph by 6 different concepts, and also the ability to see all the social network as a network, right? In our production product, we have all this information in dashboard, so it's more easily to access, and we have what we call receipts. It's like functional missions where you decide what do you want to do within graph. For example, I want to find experts in my environment, and it apply all the filters you need to find those experts in your environment. I want to find the focus of a reputational crisis, online crisis, these kind of things, okay? They are telling me I need to hurry up, sorry, I thought I had more time. So now I will talk to you about another very interesting product, also based on Twitter, that it's called Social Button. Social Button is a product we've been using with political parties during the last election process. It also fits very well with companies in general, with non-governmental organizations. It allows, I will go directly to this one, it allows companies to create news in like a WordPress environment and distribute this news to their sympathizers, to their affiliates. These people will receive that news into the mobile phone as a native notification, and from this notification they can tweet directly once they have read the content, okay? The good thing and why we use graph analytics in this environment is that a company or a political party can have thousands of followers, thousands of sympathizers, but with our algorithm, we decide to whom it's going to be better to send this notification. So they will generate enough social contagion, so we don't need to send them this notification to everybody, okay? We also help them during the political campaign to understand how their message were arriving to the rest of the Twitter network, okay? If they were too endogamic, or they were very open in these conversations. And another product, another kind of analytics we are performing is the web navigation analytics. We provide this kind of services to telco carriers, and we create a graph depending on the navigation logs, okay? So we create a link every time a user visits 2 different domains, and applying those techniques we see before, like the degree centrality and community detection, we are able to identify group of domains that usually are navigated by users together, and with a text classifier we are able to classify the kind of navigation that their users are having, okay? And we provide them with this kind of graphs. We identify the clusters. For example, this is a fashion cluster with almost 90% of the nodes are fashion domains. But there are also interesting things like, for example, online players, online music players. So we have online music players in the cluster of technical webs, in the fashion web. So if you want to put an advertisement in about your new pants promotion, you should use the player who's in this cluster, for example. This is one of the business cases we are using it for. In other cases, for example, when we start with graphs, we help Piro with their online social networks. This is a Facebook game. Every node is a player, and there is a relationship created once every time a player interacts with another one. And this is a visualization of how the big the giant component is generated and then destroyed. Our purpose was to understand the process of the giant component generation and try to keep it as much as possible, okay? We have also performed using betweenness, the algorithm we see before, using betweenness, centrality, and community detection. We detect all the communities in a social game for mobile, and we try to identify those nodes linking communities to encourage them to make people from one community participate with the people from the other community to improve the engagement in the game. So people who are starting to get bored because they are playing all the time with the same people find new possible games in the game, okay? I have plenty of cases. Of course, in a content-based company like ours, we need to implement recommending engines models, okay? So, of course, we have implemented the state-of-the-art in collaborative filter and content-based filtering, but we also have a very nice implementation based on graph, and it's very simple, but it's performing as well as the state-of-the-art algorithms. And it's just based on, we have 1 billion records every month logged from advertising, and we try to improve the performance of our ad server, okay? And the ad server is ours, and we auto-promote our content. So we create a graph, and with this graph, we make a special technique, that's a projection. We link apps between each other, depending on the number of users they share. We apply an aging algorithm to decay the value of these shared users. And when we have a user, for example, using this application of news, then depending on the edge of those links, we decide which application we should show to this user. In this case, for example, this one with the highest value in the links connected to this one. And I will show you more. I can, when we finish, I can show you more if you are interested. But I think I need to finish, sorry.
So, thank you.
It's 3 o'clock in the afternoon. We are in Spain, Malaga, 100 meters from the beach. So it's perfect time for siesta, not for graphs. So I really appreciate your presence here. I will try to do my best to keep you interested in the presentation. And I can promise you that this is going to be probably the easiest to follow talk during the whole event, okay? Just to ensure you're in the right talk, my name is Fernando Pérez, and we are going to talk about graphs, why graphs are so powerful tool to model information and to extract insights from them, the problem of big graphs, why big graphs are so difficult to compute, how big data can help us to process this kind of graphs. And as we are in the business track, we will show you how we are using big graphs and big graphs analytics in our business environment to gather insights. Let me introduce you a little bit our business environment. We work for a research lab called Bitmon Lab. Bitmon Lab belongs to a group of companies, most of them dedicated to degrees oriented to engineering, game development, computer science. We have also degrees oriented to the digital business administration, and of course, animation and digital design. So it's one of the key factor of success from the university that we are able to mix students from all the different degrees working together to bring an idea into the market, from the idea into the design of the idea, the construction, the development of the idea, and the viability of the business from behind the idea. All them working together, trying to prepare the entrepreneurs of tomorrow from this country, okay? So now let's go into the graphs theory. I will make a little introduction so you can understand better what I'm going to to tell you later. How many of you have seen this image before? Okay, quite a few. I'm showing, this is the city of Kroningsberg, and those are the bridges of Kroningsberg. And this image is ubiquitous, it's in almost every presentation about an introduction to graphs, okay? So for this case, I wanted to be a little bit original, and I've changed the image. It represents the same concept, the city of Kroningsberg, and its bridges. Why do I show you this to those who haven't seen this before? Because graph theory is supposed to be born with the publication of Leonard Euler paper, 7 Bridges of Kroningsberg, where he solved, in fact, mathematically, the problem of is it possible to visit each part of the city, crossing one and only one each of the bridges, starting and finishing in the same city area. And part of the key of success of Euler was his capacity of abstraction from city areas and bridges into the concept of nodes or vertex and links or edges, okay? and he demonstrates that a graph at least needs to have all of its vertex, all of his city areas in this case, need to have an even number of bridges or links in order to have an Eulerian cycle. Okay? Now we are working in another film. Another important part from our company is Pérez Studios. How many of you have played Commandos anytime in your life? Okay. My generation has spent hours and hours. Our notes in the career go down because this game, it was #1 in many, many countries in Europe. It's considered to be between the top 10 games developed in Europe ever. Now Piro is developing games for social networks, Facebook, Orkut, and recently, obviously, we are developing games for mobile devices, iOS and Android. Our last 2 titles, Evolution Planet and Super Soccer Club. Super Soccer Club has been awarded with the best iPhone and iPad game in this year Game Lab event, the most important gaming event here in Spain. And last but not least, we have the UTAD, the Universidad de Tecnología y Arte Digital. As you can imagine, with all this knowledge and expertise in the entertainment and digital industry, in this university, we teach our students all this knowledge, and it's mostly focused in 3 different kind of degrees: content creation, digital content creation, and digital entertainment, okay? What usually is known as the digital economy. The main company from the group is TED Worldwide. We are near 2,000 employees all around the world, with presence in more than 70 countries in the world. And our natural partner are telco carriers, okay? We are helping telco carriers in their digital transformation, providing them with digital marketing, mobile financial services. We also provide them with analytics, top-up prediction, churn prediction, customer segmentation models, and they are the natural partner of TED. We also have a film animation studio. How many of you have seen Planet 51 or Mortadelo y Filemón? Okay, we started in 2002. In Ilion, there are more than 350 experts from all the world working there, from engineers, programmers, to digital designers. Our last title was published 2 years ago, Mortadelo y Filemón. Both films were awarded by the Spanish Film Academy with the Goya Award.